Hello everyone, welcome to my channel. Myself Vasant, an undergraduate from mechanical engineering. In this video, we will be dealing with 3D cases where force acts and how we can represent the force that acts in a 3 dimension, and with help of vector how we can add or we can resolve the 3-dimensional forces. That's what we are going to see here. So let's first see a position vector in 3-dimensional. For example, we represent a coordinate system, that is a right hand coordinate system. With this coordinate system we define a position of a point P. For example, this is the right hand coordinate system. The thumb points along Z direction, so as our right hand curls towards, it calls from X to Y. So such way I can establish this coordinate and the position of this point P. So this is a graphical way of representation, and one can easily see what I express by this diagram. So I express the position of this point P with respect to origin. So I can't express always in a graphical form whatever positions. If I have to write 10 different positions, I need not to draw all the time graphical way. So we develop a mathematical model, that is a vector that represents this position P. So let's see what this position vector P represent. So it actually represent is we have to move along distance of X in I direction, Y the distance Y in J direction, and the distance Z in K direction to reach P. So this combinedly I represent as a position vector or vector. So R vector defines how much distance we have to move to reach point P from O, that is xi plus yj plus zk. Similarly, if we have this F vector in 3-dimensional, so how we can represent this in a mathematical vector form? So this is a force vector. Let's see how we can express this in a simple form. So we have already discussed a triangular way of resolving forces. So first I take this triangle, right angle triangle. So these two sides, that is one side which along xy plane, another side which is parallel to z axis. So I represent the force along that side is if fzk, and this f dash that acts on xy plane. So these two can combinedly represent this F vector. So that what we have already dealt resolving along triangle. So similarly I resolve further this f dash into 2, so that is fx I fyj. So with this combinedly I can represent F vector as fxi plus fyj plus fzk. In previous case, for the position vector, we can generally you can accept without any manipulations, you can accept this position vector represent this position of P from O. But here you can see we have used this triangular resolution to come up with this conclusion: F vector is equal to fxi plus fyj plus fzk. So with this I can state I can represent F vector as a 3 components. We have already dealt with rectangular components, that is 2 components in planar forces, but here 3-dimensional we represent fxi plus fyj plus fzk. So this resolution helps us to find the magnitude of force vector in an easy way. As we can see, this is a triangle, so we can easily find the resultant of F vector by Pythagoras theorem. Similarly, from this triangle I can solve for f dash. Combinedly I can state that F vector magnitude can be easily solved by this way. So you can find magnitude by this way. So coming to direction, how to find direction of F vector? So we represent F vector in the form of unit vector along F. So this we find by dividing F vector by magnitude of F. So by solving for this, we represent, you can see here, the numerator F vector has a magnitude of Newton. Similarly, the denominator magnitude has the same Newton. So cancelling that, f cap vector, this is how we represent this unit vector, is unitless. So it's only defining a direction along which it acts. So if someone asks to find, knowing F vector and F cap vector, you can see here F vector f vector is completely defined magnitude and direction. So you can see here first magnitude cross direction, so that gives the f vector. So this way we can define the direction if we want to, or if the direction and magnitude are given separately, we can combine that to form this f vector. So that's what I like to focus here. So coming to discuss it further, you can see here I take the other case again to find the f cap vector. So we see whether this f cap vector only defines the direction. So you can see here another way of representing this f vector is by defining angle it makes with x, y, z axis. So first I take in the first picture, you can see here. So first let me say that I know this angle that is between f vector and z axis. By this I resolve f vector along z axis. So along z axis f vector is f cos gamma. Similarly, I take this triangle, you can see here, if I assume this angle is completely known, that is it makes alpha with x axis, so I resolve along x axis, so f vector along x axis is f cos alpha. Similarly, I take the triangle, so you can see here I have angle that is defined between y axis and f vector, so I can resolve the f vector along y axis, that gives me with f cos beta. So combinedly I can see here f vector can be defined as three vectors, that is f cos alpha I plus f cos beta j plus f cos gamma k. So with this you can see here, so I can represent this f vector by this way. So if I divide, you can see here the next step to find the unit vector, you can see here all the magnitude term goes out and this f cap vector only has the direction. You can see here cos alpha I plus cos beta j plus cos gamma k. So this completely defines the direction, and we can already discussed how to find magnitude. So this way you can see here, as we already know stated, this f cap vector will have only details about direction, and also you can see here we divide by magnitude, so the magnitude of f cap vector will be 1. So that makes us to state this value is also is equal to 1. So f vector is equal to direction, that is f cap vector, multiplied by magnitude. You can easily have an idea of how to see the force vector in 3D and how to find its magnitude and how to find its direction. So if individually the direction is given and magnitude is given, we can combine that to find f vector. So by representing a vector in this format in 3-dimensional, I can represent or I can add any number of vector. You can see here I have two vectors, a vectors and b vectors. So if I want to find the resultant, I simply add x components, y components and z components. This way I can make sums of infinite number of force vectors easily. So only an algebraic sums along x, y, z is sufficient to find the resultant. So this way representing a force vector in this format helps us to find resultant vectors easily. Let's take an example here. You can see here we are given a case in which f1 vector is completely defined. We have the resultant vector, the resultant of f1 and f2. So I need to find f2 vector. So f2 vector is the question asked. So how can I solve for this f2 vector? You can see here f4 vector, the resultant vector only acts along y direction. So I can state that summation of y is equal to 800. Similarly, you can see here it doesn't have components along any other direction, so I can state this way is equal to 0 and summation of fx is equal to 0, summation of fz is equal to 0. This way you can see I have three equations, so I can solve for these three unknowns, f2x, f2y and f2z. So by finding these values I can solve for magnitude, which is easy, direct way of substituting. I can find the magnitude. Similarly, if I need the direction by this form, you can see here I know f2x and f2 value, so I can find the alpha 2 value, beta 2, gamma 2 value. By this I can solve for the value of alpha 2, beta 2, gamma 2. So this way we can solve any kind of problems that's given in 3 dimension. So further, I like to explain another important concept, that is, for example, you can see the case here, a rope which we can I state that AB is defined, the position or the rope AB is defined. So by this definition I have to find the force vector given only the magnitude of force vector. So how to solve? So as I already stated, unit vector only defines direction. It doesn't mean it only applicable to force unit vector. You can see here this AB vector has a direction that can be taken out. So find by R vector, I divide the R vector by magnitude, that gives me with only the direction. So only the direction of the unit vector of line AB, that is equal to this force vector direction. So same direction, this rope also have the same direction as the force, because the force is acting on the rope. So with this I can solve. You can see here, instead of substituting, you can substitute directly u in terms of unit vector for the force that defines the direction of force. So I restate this with this picture. You can see here the p vector is defined. So the unit vector is simply p vector divided by the magnitude of p vector. So you can see here, if I want to find the p vector having the magnitude, how can I solve? Let's take the case like this. So first I substitute the magnitude of p, multiply it by direction of p. Similarly, if I want to find, you can see here the magnitude of p has meter, so the vector will come as meter. Similarly, if I want to find the force vector, so I substitute the force. You can see you can see here the force is also acting along the same line. You can say it as a rope, so it acts along the rope. So if I want to find this f vector, so first you can say this have same direction as p vector. So p cap vector, that is unit vector of p, the direction of p is equal to the direction of f. So by this I can substitute like this, the direction of f vector, that is direction of f vector is equal to this direction of p vector. So I substitute p cap into magnitude. So that gives me with this force vector. So this way, if a force acts along a line, so the force will have same direction as that of this line, so that you can take that as a rope. So thank you for listening. Make sure you do subscribe for my channel to see the future updates.